Hi, we're going to look today at the Vernier instrument that we use for the kinetics measurements. That includes a data acquisition unit here and a colorimeter here. So if you step right over here, you can see this is the data acquisition unit. The absorbance will read directly onto the scale there. That's a number you'll have to write down some of the time. Over here you've got the colorimeter. And you can see right now it's set for 565 nanometers. Most of them will be. If it's not set for that, you have to change it. You can do that just by using the arrows there and cycling the light until it comes back to 565 nanometers. Now the first thing you're going to need to do is calibrate the instrument, and for that we're going to use just a sample with some distilled water in it so it's perfectly clear. You'll notice that the cuvette here has the cap on top. Always seal the cuvette before you put it in, even when you're in a hurry, as you will be later. But don't get us a breakage fee because you're in a hurry. Put the cap on tight, open the compartment here, and you can see if you look in, there's a little arrow pointing. You want the clear sides of the cuvette to line up with the arrow. So you drop that in, the arrow is telling you how the light goes through. Slide it shut. And your first order of business is to calibrate the sensor. So when you want to calibrate, just press the big CAL button there, and that tells the instrument it's loaded with a blank. There's just solution, there's just solvent in there. Nothing should be absorbing light. And after you finish that, if you look over at the absorbance reading, it should read 0, which means that it's correctly calibrated. Now, that's boring. You want to be able to take measurements with solutions that contain color. So we'll take the calibration unit out now. This is a sample that contains the crystal violet dye that you use for this experiment, and I'm going to put it in here. And again, I'm lining it up so that the flat side is in with that arrow. I close it up. I look back at the absorbance reading, and I see the absorbance now is slowly rising. We'll let it settle off. It comes out to about 0.521. So that's the number you would write down then for the absorbance with that concentration of dye under those circumstances. Now that's the easy part, that you're going to do that in the first part of the experiment so that you can work out what the extinction coefficient is for the dye. That is how much light each molecule absorbs. But you also want to get the kinetics. So we're going to take that sample out and set it aside. And instead, we're going to start working on the second part of the experiment, which involves preparing solutions of the dye that are degrading with time. If you mix the dye that we use, the crystal violet here, with sodium hydroxide solution, a base, it decomposes, and that means it decolors. So what we're going to do is we're going to use syringes here, and I'll explain how to work with those in a second, to add amounts of the base and the dye to the cuvette. Then we're going to quickly put the cuvette inside the container and start taking data, and I'll show you how to record that. But the point is, the instrument will record the absorbance, how much light is absorbed, as a function of time. So for each time, it will record the data, and you'll be able to watch how the dye degrades. Now when we do that, we want particular sampling intervals. So one thing we have to worry about here is the rate at which we take samples. This one is currently set for 3 samples per second, and it's set for a duration of 5 minutes, which is more than we need. So let's say we want to change that. We will change the interval to, let's say, 0.5. And now it's taking a sample every 2 seconds. Whatever number the instructions say to use, go ahead and set the sample interval for that. In terms of duration, you don't need 5 minutes. Let's just make it 1 minute for this. So we'll make it 60 seconds. This is just the demo run, and again, you can set the values according to the ones in the text. Just follow the pattern there. So okay, so now we're okay. We've got our sampling rate set. So now we'll prepare the solution. We've got everything lined up. The sampling is the way we want it to be. I'm going to leave the hinge open on the colorimeter there so I can just slip the cuvette in when it's ready, and I'll close it. I'll press that green arrow there that tells it to start recording, and then we'll watch it go. All right, so what I've got here is a syringe containing 1.5 milliliters of sodium hydroxide, and I will just add that to a nice clean cuvette. Now at this stage I don't have to do anything fancy, I just need to get an accurate measurement in there. Now this is where we have to be a little more careful. I'm going to show you how to load the syringe on the crystal violet, and then I'm going to explain to you what we have to do to get it into the instrument in a way that's giving us good data. All right, so when you read a syringe, you always read the volume based on the position of that septum that is closest to the needle, right? If you look in, you always see there are 2 septums there. you check where that septum closest to the needle sits against those gradations. We want it to be at 1.5. So what I'm going to do, I'm going to suck the crystal violet into here. We're getting bubbles, but that's okay. I'll show you how to deal with those in a second. We're going to go well past the line for 1.5 because we're going to have to get rid of the bubbles, and we want to make sure we have complete volume. Now you can see you've got the solution up to about here, then you got the bubbles down here. We turn it over, just like you see in the movies, okay? And you see how the bubble rises to the top. When the bubble has risen to the top, then you need to force it out. And you can actually watch the solution kind of come out the top. When you start seeing it go like that, you're good. Flip it back over so there are no bubbles present anymore. You can check and make sure none of them rise up, but there are no bubbles there. We're above the line where we need to be for the 1.5 milliliters, but that's okay. Now we can just squeeze some out until we get down to that 1.5 milliliter line. Whoops, looks like we do have a little bit of a bubble there. Let's see if we can get rid of that. If you get into trouble, just tap it like that. All right, I think we overshot by a bit, but that's okay. I like to make a few mistakes as I go just so you can see how easy it is to clean things up. But there we go. Now we got to line that septum up with the 1.5 marker. It's a little hard to see, but we'll get there. All right, there we go. We're at 1.5. Now this is where it gets interesting. Make sure that the cap is near the cuvette, ready to go. Make sure everything is set up the way you want it. As soon as we start mixing the chemicals, the reaction is going to start. So now we don't want to rush things to the point where we spill anything, but we want to make sure that we get the mixed chemicals into the sample as quickly as we can so we get as much of the reaction as we can. If we start really late, the dye will already be degraded to the point where we can't see any change in time. So here's how we're going to do that. I am going to inject the tip of the syringe here below the level of the water, and then I'm going to squeeze down to start injecting the dye, and you can see it kind of clouds in there. Now you want to go reasonably fast here, but not so fast you make bubbles. And then just give it a few good stirs with the tip there. Cap it, slip it into place. When everything is ready, press that green button. Now watch the, okay, there we go. Now you want to watch the green button there. If you press it too hard, it can go back again because the green button appears in the same place as the red button for stop. But now you can see it's recording data, you can see it going there, and you can see the absorbance on the one axis and the time on the other. The absorbance is decreasing as a function of time, and that's what you want to see. Now these instruments are not perfect. Sometimes when you watch these things go, what you'll see is a sudden drop somewhere, a discontinuity. Now, if that happens after the first 30 seconds, you're okay, because you're only going to use the first 30 seconds of data for your calculation. But if it happens in the first 30 seconds, you're going to have to repeat the run, because that means there was an instrument failure, you have to try it again. That's okay. You got plenty of time to do this experiment. There aren't that many runs to it. So don't be afraid to throw away runs if they don't work. All right, so we'll let that run finish just a few more seconds, and then I'll show you how to go about saving it. This part is about as exciting as watching paint dry, but there we go. All right, and you can see it's starting at absorbance maybe about 2.7 there, and it ends absorbance about 1.5. This rapid drop off initially, that's what you'd expect. The rate always goes faster at the start of a reaction like this one, and then it tails off as you move down. So this looks like pretty good data. So now we need to worry about saving it. And remember that we want to export this so that it doesn't just sit on the drive here. It's in a form that's easy for you to read on a flash drive. So we have a flash drive here. The USB port is up here next to the power. We'll plug that in. And now we'll go over to File. And we'll do Export, not Save, Export. If it comes up. There we go. All right, and you can see we've got some old data on this thing. Ignore that, not your data, you can't use it. But what you want to focus on is a little icon up here. In the corner up here, there's a USB icon. Press that. All right, so this particular All right, there we go. So this USB drive also has some old data from 2 students. But again, we can ignore that. We're going to enter our own data. We'll do that up here. I'll give it a name. The instructions say to use the yours and your lab partner's name. That would be really helpful because there are a lot of people who use this equipment. Don't get cute, just please keep it simple. I'm just going to call this demo. All right, we'll save that. Now we'll hit OK and it'll export it. All right, and now we can check that. We'll go back and take another look. And there we can see we've got our demo.txt. And by the way, that .text suffix, that's important. You want to export as a text file so you can read it in Excel with Excel or some other program. The native format that LabQuest uses is called .qmbl. That's one that can only be read by Vernier's programming gear. Now that's okay, you can go to www.vernier.com and download a program that'll read it for you to actually take that home, but the text is easier to work with. And again, as stated in the instructions, it's probably safest to save it twice to the flash drive because sometimes the drive doesn't work quite right. So you would just go through the same procedure again. I named it demo.txt. You would save it again as demo.to, and then you can be sure that one of them will be properly written. That's all you need to know. One other point I'm going to make: when you are using the LabQuest app to make runs, you're going to make several different runs with different conditions, and you want to make sure that you save each one separately. If I were to start this run again, it would try and overwrite this data, and you'd lose it. So the way to prepare for the next run is to click on the file box icon here. There we go. Now I've got a blank space here, and if I start recording data again, it will start. Now there's nothing in there. Nothing is going to happen right now because we let the sample finish. But the point is, if you want to save multiple runs, just click on the file box icon here, and it'll give you a fresh space to save things each time. Before we go, why don't we take one more look at this magic sample we put here, and you can see the solution is pretty much clear now. And the reason for that is that the dye was all destroyed by the base. So you can check this on the way out. It's just a nice way to make sure that the reaction actually ran as you expected it to. If you still had a lot of color in the solution, you'd know something was wrong. That's all there is to it. When you're done, take the USB drive out. Take it up to your instructor, have them make a copy onto the computer in the lab, and go home. Thank you.